Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, my name is Marty Humphrey. I'm an assistant professor in the Department of Computer Science at UVA. This is a largely CS computer science related talk. Although I want to begin with history, philosophy, and religious studies. And then we'll move into technology later. So we heard what the grid is. I like presenting this slide from Ian Foster just to ground what we're talking about. Resource sharing and coordinated problem solving in dynamic multi-institutional virtual organizations. Another slide I lifted from Ian. This is the last one of the talk. There's a lot of these grid things that are going pretty well right now. There's a lot of them out there across the world. Much of them are based on technology called Globus, and much of them are running on Linux platforms, basically. How many can talk to each other? Well, that's another talk. Recently, in the standards body called the Global Grid Forum, there is a strong effort to produce an open grid service architecture, OGSA. And so the effort has been to take the so-called traditional grid protocols and software and really leverage web services. And so for a lot of people in the audience, you've heard this many times, but some people have not. There's a belief that web services alone is not the best route, but are not the only route, and is not sufficient. And so there needs to be something built on top of it. At first, this was something called OGSI, Open Grid Services Infrastructure, which is a layering on web services. More recently, it's this thing called Web Services Resource Framework. But what I want to emphasize here is that the grid, by its very nature, is going to be heterogeneous. Absolutely heterogeneous in terms of policy and mechanism, software, protocols, underlying platforms. Okay? And so what I want to talk about is some effort that my group has been doing at the University of Virginia, specifically to accommodate this heterogeneity. Okay? And the way I like to phrase it is we want to construct a grid where we can exploit the native capabilities of all the platforms. So what we're doing is largely trying to exploit and leverage the capabilities of the Windows platform and all of its associated tools into these grids. And so what we started with was an infrastructure based on OGSI on .NET around 2002. We then switched that to WSRF-based infrastructure, again, trying to build on the standards and influence the standards of the Global Grid Forum and again, exploit Windows. In doing so, we had an explicit goal and a conflict of we want to recognize the past history in grid computing, including the successes and failures and the arguably existing legacy support and base. But we also wanted to analyze it from first principles and throw it away if possible. But bottom line is we didn't want to, I don't know if you can really read that word, but we didn't want to build architectures. We wanted to build software that worked. Okay? So no big architectures. So I'll show you an architecture slide. So in the faculty summit in 2003, I presented early work we had on OGSI that had constructed this system for biomolecular engineering, based on OGSI. And so we had our scheduler here, and we had all sorts of services on the back end. And we had a user who would submit a job, the scheduler would figure out where to put it, and then we'd get notifications and that sort of thing. We also started to exploit WSRF on the .NET platform in a similar style of system in which we have a client, a scheduler service, information services, notification broker, and all those sorts of things. We also had decent performance on WSRF.NET. This is a slide from a talk we gave at HPDC over this summer, where we essentially were trying to, again, WSRF.NET was trying to build on standards that were emerging from the Global Grid Forum so that we could build these grid services on .NET, just like we could build them on Linux or any other platform, and get them to talk to each other. And this is our performance. The details are not necessary. How high all the graphs are, that is relevant here. We had pretty good performance with various primitive operations. That one was with no security turned on. This one's with X509 signing. The point here is that the .NET platform and our layer on top of it had solid performance, and we could get these things talking to each other. Well, that brings us to a point where we got to assess the state of the world. We want to build this grid and leverage web services. The problem was web services were not entirely cooperating. They're not converging necessarily, and so we kept having to hit this moving target. And so that's still, to this day, a problem with the project. But throughout the effort, our goals included doing whatever it took, including nothing. We accept that doing nothing and just leveraging the infrastructure, that's fine, that's wonderful. We're not to that point yet. We also wanted to build the Globus protocols and services on .NET. Again, these were the things that those existing grids were talking about, and there's a lot of good protocols for grids that are wrapped in there, and we want to exploit .NET.
Why do you want to do that?
Exploit .NET? Because we want the software infrastructure to just be there. We don't want to have to write software on top of it. You know, we want to fire on a box and just have it be there, right? It can just automatically start participating in the grid. The software development tools that everyone knows and loves is still there, and there's nothing special about it. I was at a talk at the Grid Forum, and someone said the grid will succeed when we stop having to train people how to use it. Right? And that's a theme here.
So when you talk about heterogeneity, you're not talking about necessarily vastly different platforms. If you want to build everything on .NET, you're, for example, not going to be building software for Solaris.
Good question. Yes and no. We want to build or analyze the .NET infrastructure to allow it to talk to these projects that very capable people are producing on the Linux platform, right? Dennis and Beth, for example, they're doing some very great things on both .NET and Linux, and we want to just exploit that. Okay. This is sort of a tangent, but I'll mention it. The Global Grid Forum 2 days ago actually very proactively decided to build to try to construct a standard based on WS management, which is a Microsoft-led effort. And so what we need to do in our project, and we've been doing it somewhat, is to attempt to leverage WS management as a platform by which to construct services, grid services on the Windows platform, We did a little bit of analysis for a supercomputing paper that will appear next month, I guess. So to cap off the religious studies argument is that WSRF is one religion, arguably. Here, WS management is another. The Open Grid Services architecture is going to move toward trying to construct the hourglass in which we support WSRF and WS management, and we layer our grid services on top and our grid protocols on top. The desire is that these two eventually merge, but we're not sure when or if that's going to happen. Now, more results-oriented. Part 2, science and engineering. So what we're doing is applying those the software that we're developing for the project, WSRF.net, and we're building a campus grid at the University of Virginia. The key things here are we have a number of Windows platforms and we have a number of Linux platforms, and we're going to try to get this all working together into a common grid infrastructure. This project is supported mostly by the National Science Foundation. Another way of looking at it is set up here. We have one of the portals that Dennis was presenting a moment ago. We use that as the infrastructure on which to interact from a human perspective, a user perspective, with the rest of the grid. And I'll show you the rest of the talk is a sequence of screenshots from interacting with our grid based on that portal. So we have our campus Linux machines that are running software based on the Globus toolkit from the National Science Foundation. We have a campus authorization server here that was run prior to our trying to do this, and we're just tapping into it. We also have a campus authentication server that, again, was run prior to our constructing this effort. So again, this is going to be some screenshots. My abstract that I submitted promised a live demo, but my wireless is not good enough for me to do that right now. So I'm going to step you through how we interact with this portal to submit jobs and analyze data. So this is the first screen that comes up. This is the portal entrance. If you click on that, which is very difficult to read, this is the button that says log on to my UVA via NetBadge. That is a mechanism to connect to the campus authentication source. And so if you click on that, you get this screen. This is a front end to the authentication source. If you fill in your username and ID there, that checks with a central campus server. If you are successful there, then you come to this screen where you have authenticated to the portal. And now what you need to do is acquire credentials to execute grid jobs. So the portal is password-based. The grid is largely PKI-based. And so if you hit this button here, which says Get New Proxy, you will be prompted to this screen, which will allow you to interact with a credential server to get your credential back. Again, this is necessary to submit jobs to the grid, which is a public key infrastructure based. So the first thing I wanted to talk to you about is exactly what John was mentioning, or alluding to. We have built support for GridFTP on Windows. As Dennis mentioned, the dominant mechanism to transmit, to move large data sets in the Linux grid side is GridFTP. And so by building it here, we can get the two systems to talk to each other. This is the architecture. Again, I said we didn't do architectures, but this is the architecture of the Windows implementation of GridFTP. Here's some performance numbers from it. Only thing to really get out of here is this is the GridFTP on Windows. On smaller size files, it's not so hot, but on larger size files, it does fine. So back to the portal. So what you might want to do as a user of the grid is move data around or analyze data. This is, again, a very low-level mechanism. This is the portlet that is being built in OGCE. So if you come to this window and you click on the files, you have the opportunity to select one host or a couple hosts. At this point, for instance, if you click on the this particular host, Opteron 1, this is a Linux box. This is what shows up. If you then click, if you go back, this is the same appearance, the same look and feel, but this is back-ended by a Windows box. So this is our GridFTP server on Windows that's answering the portal's request to look at the data. So we've also embedded in there is the fact that we also have this running on a Windows cluster. And I don't want to, Carol's not here yet, but I don't want to steal the discussion. But Carol tonight is going to be talking about a Windows cluster. We recently installed the cluster and we got this working. And I'll show a few screenshots from using that. But again, this is GridFTP-D running on the Windows cluster, the front end. And again, an option here in this portlet is to move data between hosts. On this side, we have a Linux-based host supporting GridFTP, and here's our Windows-based host supporting GridFTP. And you can click on something like that, we'll download it to your desktop. Clicking on something like that will move it back and forth. Fairly primitive, but it's a necessary step in moving things around. We also have implemented another important grid protocol on Windows. This is the GRAM protocol. GRAM protocol is for remote execution. And so this is the architecture. Why did I say we don't do architectures? This is the architecture of GRAM on Windows. So if we come back to the portal, then this other tab here is for job submission. The screen here is showing a particular Linux box with the Globus toolkit 2.x on it. And if you hit the run command, then you could execute jobs on the Linux backend. Well, similarly, we're trying to preserve the look and feel of the portlet here. And so up here, you can't read it, but this is a Windows Server box. The provider is in other words, what protocol is this thing going to speak? Again, Globus protocols. We have an executable that we mentioned, or that we specify here. We give arguments to it, a standard output file. And then if we execute that, what this is actually going to do is it's going to write the output of the ls command into this particular directory. And this is just showing the result of it. The particular output file that we were attempting to do to produce was this dearlist.txt. What I'm doing here is remotely executing this job. It's a trivial job in this case, but it's writing the output to a file on the local machine, which I then could get via GridFTP. And I think the last thing I want to talk about is how this works on the Windows cluster. So this is the Windows cluster node. Again, with the GRAM interface, we're going to first just execute a job that executes hostname on the Windows cluster front end. And if we do that, then this is the result written into the file system, which you again would get via GridFTP. And that's the result of the file, WinCluster1. And lastly, this is an example of we're going to execute a batch job. I'm sorry, I have two more examples. We're going to execute a batch job on the cluster. This is the window on the console of the cluster, just showing you that it actually got into the queuing system on the cluster. And lastly, we're going to execute an MPI job on the Windows cluster, again, via this comfortable look and feel. The output of that job that I'm sort of screaming through to keep us on time is called palace.txt. So this is the result of executing the MPI job on the Windows cluster. And that's the actual result of the file that I got from GridFTP. So to recap to this point, again, what we're trying to do is to sort of accommodate the strengths of the existing grid infrastructure, all those projects that I identified at the very beginning. We want to accommodate the existing infrastructure there and try to leverage the Windows support too to create a truly seamless computing infrastructure. So what we need to do in the future is to harden some of this code. We just got the Windows cluster bits within the last month. We made some modifications for that, and so we have to harden that and fix that. We also have a different authorization server based on AZMan from Windows Server that supports a role-based access control that we're interested in perhaps exploiting in our campus grid as well. And I mentioned we want to refactor WSRF to utilize this WS management. So I mentioned this, that again, the emphasis is not to build and ignore what has been done in the past. And so we're going to try to exploit Windows. We think we're doing it fairly well right now by focusing on GRAM and GridFTP. GRAM is the protocol for remote execution. GridFTP is for moving data. We have instantiated this at the University of Virginia. And so we have a decent existing Globus-based infrastructure talking to a Windows infrastructure, and we can move data back and forth. Another thing we want to do that I haven't demoed, but we can actually do it, is to take that portal, submit jobs to the TeraGrid, which is the National Science Foundation computing infrastructure, have that job yank data from my desktop via GridFTP, execute the job, and then push it back onto my desktop. And so I just come in the morning, and it's sitting there on my desktop, having executed the job on the TeraGrid. So we think that's pretty cool. And that's it. I guess I got us back on schedule. Any questions? Yeah. No, sorry. We modified our software package that sits on top of the Win cluster bits. So we didn't modify Win cluster bits. Dennis?
So I was joking earlier about interoperability between the grid. You've got GridFTP and GRAM going between your .NET implementation, and I assume it's Globus
4.
4.0.1 or 2 or something.
Yeah.
That's very impressive. It's something that
So I came back from the Grid Forum earlier the week, and I sat down with one of my guys and said, okay, I got to put together these slides, show me what we can do. And we kept going through stuff, and frankly, I was surprised that it kept working. And so this was all from slides constructed yesterday, and yeah, it's pretty cool.
that notion of TeraGrid job submission and getting the stuff, pull it off my desktop, and I want to see the results back on my desktop in the morning. I don't have to go off to some remote server and come around for that. That's going to be very, very popular capability.
Yeah, we hope so. I mean, we recognize that GridFTP is a very low-level mechanism, and arguably you don't want that interface to a lot of your data. As Jim was mentioning, you don't want to think about moving large files, but sometimes you do, and you need that low mechanism, and so we're hoping people can build on top of it.
GridFTP is what we get for now. Until we get something better, we've got to move.
Right.
So how do you decide where this is
Yeah.
got data somewhere else on the grid. And the model is to use GridFTP to move those data to the place where the computing resources are, and then do the computation and then do something with it. Is that too simple? I mean, that isn't the bad way to work. So
Okay. Well, for one thing, GridFTP supports partial file transfer.
So does that mean you can start doing your computing before all the data get there?
Yeah, you can in some situations.
But I mean, how do you, so in some kinds of situations that works.
Yeah.
You know, for example, if I've got a satellite data set and my processing is entirely spectral, so I'm just processing, the information in a pixel. I'm not looking at its neighbors, and I've got my data stored, band interleaved by pixel. Then, as soon as I've got one pixel, I can start processing, right?
Right.
But there are other kinds of things that you do where you're not operating that way. And for example, we use ArcGIS. You can't run ArcGIS efficiently over your own local network. You can, if you have your departmental file server somewhere and you're trying to use ArcGIS on that, you find you get a lot better performance. You can bring all that crap your desktop.
Well, okay. So maybe the best way for me to answer that is there are a number of grid data protocols. I was just focusing on one, which is very dominant in the grid installations I see. Are people building better, easier to use, more reliable access that may actually utilize GridFTP? Yeah, absolutely. I was just focusing on this one.
Okay, but I mean, it's not a bad first step. But you are bringing the data.
It's fairly primitive. Okay. It's fairly primitive. Absolutely. Deb?
I think there's a pretty broad spectrum. If you're from the EOS community, which has the terabytes of data, there are a bunch of people like string gauges. String gauges are a few terabytes of history through the years, and all the string gauges fit on a CD. The GenBank is 40 gigs, all of them. And you can actually download GenBank once a month and have a little copy of it. And lots of people do that. So most scientists are
Any other questions for me?